let's take a look at another problem where we're going to be determining intervals over which a function is increasing, decreasing, concave up, or concave down. All right, so this problem says if f of x equals sine of x is defined over the interval from negative 2 pi to 2 pi, over what interval is the function concave down? Okay, so once again, if we don't remember concave down right off the top of our head, we can go to the derivative behavior reference sheet. And so this says that concave down means this basic shape where it's kind of got the frowny shape of the curve. And that's when the second derivative is negative. So the first thing we're going to need to do is we're going to need to calculate the second derivative of sine of x. So f of x is equal to sine of x. And so we've got to get our derivative reference sheet as well. Okay, so this is always very handy stuff. The key things you'll want to make sure you remember are the sine and cosine. Down here, e to the x, its derivative is itself, and the derivative of the natural logarithm of x is 1 over x. Those are the highlights of that column. So the first derivative of f is equal to cosine of x. And the second derivative of f is what? The second derivative of f is the derivative of cosine of x, which is equal to negative sine of x. So that's another cool thing about the trig functions, that sine of x, its second derivative is its own negative. So that's pretty cool. So to calculate where this function is concave down, we want to figure out when is negative sine of x less than 0. Okay, and so let's solve this. So the first thing I want to do, let me get a sine x over here. So I want to multiply this side of the equation by -1, and I want to multiply this side of the equation by -1. So that'll turn this into sine x. 0 times -1 is 0. But what's our rule with inequalities? We just multiplied by a negative number, so we've got to flip the inequality sign. So negative sine of x is less than 0 when sine of x is greater than 0. Okay, so let's take a look at a graph and see if we can figure out from GeoGebra where the sine of x is greater than 0. And this is kind of a helpful thing to be able to do. All right, so there is our function of sine of x over that domain from -2 pi, which is a little more than -6, to 2 pi, which is a little more than +6. And we can see that the graph is positive over this interval, which goes from -2 pi to -pi. And then it's positive over this interval, which is from 0 to pi. So let's just look at the graph while we're here. Let's just see that this matches our intuition, that the places where the graph is positive, this function is concave down. It's got the graph is kind of got the frowny shape there, and it's got the frowny shape here where it's positive. And then where the graph is negative, it's concave up. Okay, and so the zeros of the function are exactly the inflection points where it switches from one to the other. Okay, so now that we've got that answer, why don't we go back and write our answer in some sort of fancy math notation? Okay, so we can write this either in inequality notation. So we could say -2 pi is less than x, which is less than -pi, or 0 is less than x, which is less than pi. Okay, or if we wrote this in interval notation, -2 pi to pi, We're using parentheses here because the endpoints are where sine of x is equal to 0. And so those are not points where sine of x is greater than 0. And I want to calculate the union of that with the interval from 0 to pi. Okay, so either one of these answers could be acceptable depending on what kind of notation they would want to see the answer in. So if you were solving a multiple choice question like this, you might see the answer in either one of these forms. But the key idea to keep in mind is that the process that we went through. So we wanted to figure out when a function was concave down. So that's talking about the second derivative being negative. So we need to take the derivative of the function, and then the derivative of that is our second derivative, set that to be less than 0, and then figure out which values of x satisfy that inequality. And that tells you the interval over which the function is doing the behavior that you're checking for.